Hi, I'm Phil Howell, the Director of Instruction at the DePaul School. I want to show you a method that we use with some of our students to help them more quickly master multi-digit multiplication. This approach, known as lattice multiplication, offers some benefits to students over the traditional long multiplication procedure that has frustrated many of them for years. Teachers, parents, and students can work together to evaluate whether lattice multiplication or long multiplication best suits each student's needs and skills. We want you to be familiar with this approach so that you can understand what your child is doing on his or her homework. Long multiplication requires students to constantly move their focus around the page to various parts of the problem, to jump back and forth mentally between multiplication and addition, and to carry numbers many times during the multiplication stage as well as during the final addition stage. These are some of the reasons many of our students find this procedure so difficult to master. Now let's look at lattice multiplication. In this approach, I will rewrite a problem such as 24 times 53 so that I can create a table or a grid. I'll write the first factor along what will be the top of my grid and the second factor along the side. And then I draw boxes which complete my table. Now when I multiply, I'm not jumping around to different parts of the paper and I'm not mixing addition steps in with my multiplication. All I do is I fill in each of these boxes by multiplying two numbers together. 2 times 5 equals 10. I put the entire answer in that box. 4 times 5 is 20. I put the entire answer in that box. I continue this pattern with all of the boxes. It doesn't matter what order I complete them in. I just need to complete each box. Students will spend time just working this much of a lattice problem for a while so that they get oriented to this approach. In fact, this type of table or grid can be used while students are learning their facts, and this can just be one way of them solving multiplication facts and writing in answers. Now, for those of you who want to understand why this approach works the way it does, I'll point out the bottom right hand box always shows me how many ones I have in my problem. I multiplied 4 times 3, 4 ones times 3 ones, and that gives me 12 ones. The two boxes that form the next diagonal are how many tens I have, because I multiplied 4 times 5 tens and 3 times 2 tens. So I have 20 tens and 6 more tens. The next diagonal shows how many hundreds I've created, because I multiplied 2 tens, or 20, times 5 tens, or 50, and that gives me 10 hundreds. So I have 12 ones, 26 tens, and 10 hundreds. It's not necessary to know this or to understand this in order to get the answer, but this is the background to why this approach works the way it does. Here's an example of a larger problem, 543 times 456. Again, you see that we have 18 ones, we have 15 and 24 tens, we have 12, 20, and 30 hundreds, we have 16 and 25 thousands, and 20 ten thousands. So we have a lot of information represented in a small, simple chart. And if this reasoning makes sense to you, I'm sure you're already thinking to yourself, 18 ones is too many ones to fit in a single place value for my answer. That would be 8 ones, and then there's an extra 10 that I need to move to a different place value. The same thing with these other answers as well. 15 tens is too many tens for the tens place. That's really 5 tens and then a 1 that needs to move to the next place value. Well, this approach has one more step to it that regroups these numbers without a lot of work on the part of the student. And I'll show you that step now. Remember this problem that we looked at a minute ago? Well, before I actually work my lattice multiplication, I'm going to do one more step before I start multiplying. And this is the step that teachers, students, and parents will evaluate together with any particular student to make sure that this approach fits the child's visual spatial skills. Before multiplying, the student would draw diagonal lines through these boxes. From the upper right hand corner of each box down through the bottom left corner of each box. Then, as I answer each part of the multiplication problem, I use that diagonal line to split my two-digit number. So 2 times 5 is 10, and I write the 10 this way. 4 times 5 is 20. I write the 20 this way. If I have a single-digit answer, such as 2 times 3, I'll simply put a 0 in the tens place for that number. Now what I've done with these diagonals is I've basically regrouped all of my answers as ones, tens, hundreds, and thousands. I haven't had to do that myself. The lines did that for me. And now all I need to do is add these numbers along these diagonals. My diagonal lines are going to guide my addition for me. So 2 plus nothing, 6 plus 1 plus 0, 2 plus 0 plus 0, and 1. My answer is 1,272. Let's look at another example with less explanation on my part. I'll rewrite 57 times 48 so that I can create a table. Then I'll add my diagonal lines. Then I multiply. I only multiply. I'm not mixing in addition and I'm not carrying at this point. Now that I'm finished multiplying, I'll focus on adding. Notice I need to carry here. I'm going to put my carried number just there instead of trying to put it at the top of the box. My answer, 2,736. Here's a problem of a different size, but I approach it the same way. Now I only focus on multiplying. And now I only focus on adding. As you can see, this approach allows me to solve pretty big problems with a small amount of paper space. There are not a lot of partial products lined up. There are not a lot of columns I'm trying to keep aligned myself. It's all confined and organized for me. The need to draw these diagonal lines through boxes does mean that we need to evaluate for each individual student if this approach is the best for him or her. This video is one example of the many ways we strive to teach the way your child learns. If you have any questions at all, please contact your child's teacher or contact me, Phil Howell, at 459-6131. Thank you so much.